Hello student, I am Arnab Das. Today we discuss about feedback topology. Day by day, when we proceed this module, that time we can able to understand about voltage series, current series, voltage shunt, current shunt, and obviously the effect of feedback. To explain this portion, we have to conclude into the some point, that is the initially we have to talk about introduction, then the general feedback structure, some properties of negative feedback, the four basic feedback topology, series, shunt, feedback amplifier, or this is the way by which you can go. Some reference book also given to you, you can follow that one, but not necessary you have to only follow this one. Any another kind of book you can also use for your reference. Today initially we discuss about the classification of amplifier. Before proceeding with the concept of the feedback, it is useful to classify amplifier into the four basic category, and they are voltage amplifier, current amplifier, transconductance amplifier, and transresistance amplifier. So these are the four basic category based on their input and the output signal relationship. If we consider for the voltage amplifier, this triangle, blue colored triangle is defined the amplifier as a symbol 1. So their parameter is used as a V1 or Vi for the input representation, and V0 is used for the output representation. For any kind of device, their input and output combination can be arranged to represent the amplifier term. If we consider for the voltage amplifier, that time their equivalent circuit can be written down as such, where at the input side, Vs is the source 1 voltage, and which is connected with the series source resistance as a Rs. So this portion is defined as a source portion, and if we consider for the amplifier, there the input impedance is the Ri. So this Ri is connected as series form or cascaded form. So now for the input side, the combination will be as such. This is the input side combination. Same way, if you consider for the output side, that time it will be look like this one. Here, diamond shape portion is defined as the induced voltage amplifier portion, and the value will be AV of Vi. This is the induced voltage which will be induced due to the reason of the input side. And here R0 is defined for that particular device the output impedance, and RL is defined the load impedance for that particular amplifier. So if you look for the input side, that time the two types of resistor is used to represent the circuit, that is the RS and the RI. If the condition is that this is Ri is very greater than the value of the RS, that time you should conclude that Vi will be near about equal to of V of S, because if you apply the KVL for the input side, that is for that particular loop, if you consider the KVL, if you consider the KVL for this loop, that time Vs equal to Rs into Is. If we consider the Is is the current for the source side, that time Is into Rs the voltage drop across the Rs resistor, plus of Ri into of Is equal to of V of S. So if the Rs is very less than the value of the R of I, that time this term can be absolute on there. So you can be conclude that Vi is near about, or this stands to the value of the V of S. Same way, if you consider the KVL for the output side, that time you can write down AV of Vi equal to R0 into I0. If you consider for the output side, the I0 is the current, that time I0 R0, which is plus of RL into of I0. So in here also, if we consider that R0, that is the load for the input side impedance, is 0, rather than the value of the RL, that is RL is very much greater than the value of the R0, that time this one term can be obsolete, and you can be write down that V0 is near about the value of equal to of AV of VI, which is written in here, and obviously this can be write down AV into of VS. So if you ratio between them, that is for this term, if you ratio between them, these are the two equal one, V0 is equal to AV into of VS. So from here, AV is equal to can be write down as a V0 by of V of I, or this is V0 by of V of S, and this is for the RL is tends to infinity. If the load side impedance is so much high, that time this one can be come on there. RL, if it is the infinity, that means it can be considered that output side circuit is as it tends to the open circuit form, and this is represent the open circuit voltage gain also. So for the conclusion, we can again say that for voltage amplifier condition or configuration, you should be represent the circuit in such a way the Ri, that is the input impedance, should be very much greater than the Rs, and R0, that is will be the output side impedance, should be very less than the value of the load impedance. So for that kind of cases, their AV should be equal to the V0 by of V of I. So this is the explanation for the voltage amplifier. Now for the current amplifier, what happened? Initially the source side we will be considering into the current source form. For the previous cases, we consider it the form of the voltage source. Now in here we consider the input side as a current source. This is the current source portion, where the value is the I of S, and the source voltage is defined as a parallel with the current source, ideal current source, as a R of S. And that time, if you consider as a current amplifier, that time the Ri should be very less than the value of Rs. So if Ri is very less than the R of S, that time what happened? Ri will be work just like it's a short circuit path. So maximum current will be passed through that particular path. That means no current will be passed through the R of I. Here no current will be passed through on there for the ideal cases. So here the input side current can be considered as the I of I. This one is equal to I of S. Okay. So for current amplifier, the arrangement will be in such a way that the Ri input impedance should be very less than the value of the R of S. This is the most important point, and that time should become as such, that is II will be near about equal to the, or this is equivalent value of the I of S. Now here diamond shape is indicate the induced current source, and the value is the AI into of II. So here the impedance also represented as a parallel one for the output impedance, and the load side impedance is represented as a R of L. And that cases, the condition will be that R0 or output impedance should be very greater than the R of L. That means RL will be work as a short circuit form, because RL is so less, so maximum current will be flow in this path. So here for the R0 resistor, the load side, then no current will be flow for the ideal cases. So on that particular situation, you can say that this is I0 should be is equal to of A of II. So maximum current is passed through this path. So that time I0 is equal to AI of II. That one is represented in here also. For the next equation, look that this is the equation which is defined as a I0 is near about equivalent value of the II of I0, II of II, sorry, AI into of II, and which is also defined as value of II into of I of S, that is II is equal to the value of the IS for the previous one. Here this one is given to you. Now current amplifier value will be as output current, because amplifier means, for the amplifier means, this is the A is equal to output ratio of input. So here for the current amplifier, their output current ratio with the input current. So here output current value is defined. From here you can able to see that this is II is equal to IS, and this is input current, and output current is I0 is equal to AI or equal to AI into of I of S. If you ratio between them, that is the I0 by of II, that time this will be defined the current amplifier, and obviously RL will be considered as equal to 0, or it will be work as a short circuit. So here the representation of the short circuit current gain, and this will be defined as A of I is equal to I0 of I of I. Now for the another kind of amplifier, and that one is defined as a transconductance amplifier. For the transconductance amplifier, what happened? Here ratio will be the I0 by of V of I. Again I just repeat that, gain equal to A, and this is defined the output by of input. This is the ratio. So for transconductance the value will be 1 by of R form, that is the resistive alternate term. So what will be the output is the I0, that is I you have to record, and the input side it will be required the voltage. So I of V is equal to define what, this is the 1 by of R, that is defined the transconductance, and due to the reason of this is the amplifier portion you are talking, so the mm, type of amplifier will be defined as a transconductance amplifier. So what will be that cases? So for the V of I at the input side you have to consider the KVL, or this is cascaded resistance value, that is the RS, and the R will be connected. If you consider the current term, that time that particular side you have to apply as a current source, and here the resistor RL, the load impedance, will be connected as a parallel form or a shunt form. So now the consideration will be as such, their maximum voltage will become at this position, because this is the voltage side. So Vs equal to will be V of I when the no voltage drop will be occurred at the RS position. So what type of condition it will be maintained to get this one? There should be Ri will be so much greater than the value of Rs. That means if the Rs is tends to 0 or equal to 0, that time no voltage drop will be occur in this path or this portion. So there V of I should be equal to V of S. Now for the current position at the output side, so at the RL side you have to got the maximum one current. So how can you got? If this R0 portion no voltage drop will be occurred, that is here the impedance is so high rather than the value of the RL, that time also this kind of condition, that is the maximum current will be passed through that RL side will be occur. So here the condition you have to apply for the input and output side, and that one are for the input side, this is Ri should be very much greater than the value of the Rs, and the output side the condition will be R0 so much greater than the value of RL, that is the RL if it is less it will be work as a short circuit form. So for the first condition for the input side, the conclusion will be come on there, input voltage should be equal to or tends to equal to the V of S. And if you consider for the output condition, that time the current at the output side will be as the I0 tends to equal to of Gm V of I equal to Gm V of S. G is specified for the transconductance value. Okay, so here Gm will become as a I0 of Vi, because at the first initial starting for the transconductance I already told that um, this is the admittance terms, that is the 1 by R will become as a result one. So this is current by ratio of the voltage term. So this is amplifier means the output by the input ratio. So output side you have to consider the current as the I0, and the input side it is considered as the value of V of I. So ultimate Gm will become as equal to of I0 of V of I, and the condition for that time will be RL equal to 0. So it is represent the short circuit, mutual or transfer conductance. Now for the trans resistance amplifier, that means the amplifier term will be work just like as a resistive one. So to get the resistive value, what happened, this is Vy of I. From the Ohm's law, if you just conclusion point of view, if you look on there, this is R is equal to, you know that this is the V of I. This will be defined the resistance. So this is trans means from transferring from one side to the another one. So from where it is coming, from the output side to the input side. So on that point of view, the transconductance amplifier will be defined as a output voltage by of input voltage, and for this reason here output side is considered as V0 and this is I1 for the input side. And if the input side is the I, that time the equivalent circuit will be as a current source you have to apply. If the portion is voltage, that time the equivalent circuit you have to apply by using the KVL, and here the resistors are individually connected in a cascaded or series term form. So if you consider this one, that time the conclusion again you have to make that here this path, that is the Ri, in this path the maximum current you have to flow, that is I should be equal to the value of I of S. So how it can be possible, if no current will be flow the Rs if the no current is flow through the RS, when it will be occur, when the Ri is very less than the value of RS. That means if it is the shortest short path, that time what happened, their maximum current will be passed through on there. So if you consider an analogy, then it will be so easy for the understand. Let we consider that here an highway is present and here an the rough road is present. So which one you have to follow for travel? So obviously the highway where no traffic or no kind of bumper or the hazard will be present for your path or destination, uh, for to going to the ultimate destination position. So here also for the current, their maximum path will be applied or maximum current will be applied where no resistive element is present. That is Ri when it is tends to 0. That is the Ri when very less than the value of Rs, that time I should be as equal to the value of I of S. So this is the first condition for the input side, that is the Ri should be very less than the R of S, and the conclusion will be make as a II is tends to equal to of I of S. Now for the output side, here you have to got the maximum one voltage, that is the RL will be the maximum one. When it will be happen, when the R0 no voltage drop will be occur. So that time you can conclude that V0 is equal to of Rm into of I of I, and that one is represent the induced one. This is the I1 term is present, so this is the induced current term value is defined as the Rm of Im. And obviously this is the currents not source, it will be II of Rm, that means this is the voltage term, induced voltage, and due to the reason of the input side current. So their maximum voltage will become at the output side, that is the V0 is equal to Rm into of Im. When it will be occur, when their R0 position the voltage drop is tends to 0 or equal to 0. So when it will be condition will be maintained, when the R0 is very less than the value of RL. So this is the output side condition. If you maintain this one, that time the ultimate equation will become for the representation of the V0 is as a RMIM, or it is equal to Rm of Is. So this is made or important term also to represent the trans resistance amplifier. So ratio for the trans resistance amplifier will be Rm equal to V0 of I, and when it will be occurred, when RL when RL is tends to equal to as infinity value, that is, it is work just like as a open circuit form. Okay, so these are the kind of amplifier, and if you again conclude on there for the today's class, here basically amplifier can be on the point of view of the input and the output ratio. There are four types. One is the voltage amplifier. It will be the ratio of V0 by of II to represent the voltage amplifier. For the second one is the current amplifier, where the current amplification factor is defined as a I0 by of II, and another one term is represented as a transconductance amplifier, where current amplification factor or amplification factor is defined as a GM, and this is equal to I0 by of V of I, and the last one term for the amplifier is defined as a trans resistance amplifier, and the representation will be defined as the R of suffix M, and which is equal to V0 of I. So for today's class it will be uh, up to this one, and I think next day we should be explained with the various kind of topology. Till have a good day, and I have to say thank you.